Hey everyone! In this video we're going to learn all the annoying vocabulary that we need to know for number sets and the beginning for pre-algebra. Okay, the first term that we need to know is counting numbers. The textbook definition is pretty short and sweet. All whole numbers greater than 0, also called natural numbers. I'm in a little bit more advanced math, and the term we usually use is actually natural numbers. And this would include all the numbers that we usually count with, hence the term counting. 1, 2, 3, 4, 5, 6, and up until infinity. But the only thing with this is that it's everything but 0. With whole numbers, it's the set of counting numbers plus 0. So that would be the same thing, but also with 0. Here's where it gets a little bit different. Integers, which is used quite often, the textbook definition would be the set of numbers consisting of the counting numbers 1, 2, 3, 4, their opposites -1, -2, -3, -4, and 0. So that would be all the whole, let's call them opposite of the whole, over here, negative numbers, the whole numbers, and 0. So that would be all the numbers that we're very familiar with. Let's call them like that. Now rational numbers. This is a pretty big group. The textbook definition is very confusing. It's any numbers that can be expressed as a ratio in the form of a over b, where a and b are integers and b does not equal 0. Rational numbers include counting, whole, and integer numbers. They also include all fractions and decimals, which terminates or have a repeating string. That might be very confusing to many people, but that would be basically in the group that is rational numbers. We would include 1, 2, 3, 0, -1, -2, -3, so everything that's the integers. We would include everything that's a fraction, as long as the denominator is not 0, because we should know that when the denominator is 0, pretty confusing things happen. So any normal fraction would be rational numbers. And then any decimal that terminates, so any decimal that ends, even if it goes very long, as long as it ends, then it's a rational number, because we can put that into a fraction by getting like 2 over 10. That would be 0.2. Okay, and then the last part of rational numbers would be, if it goes on for infinity, it needs to be repeating. So 0.333, 0.232323, and then like 1, 2, 3, 1, 2, 3, 1, 2, 3. As long as there's a certain pattern to it and it goes on for infinity, then it's also a rational number, because that could be expressed as a fraction. Like 0.333 can be expressed as 1/3. All of these would be rational numbers. These are we should be very familiar with these numbers. Now for irrational numbers, the textbook definition is also pretty confusing. A real number that cannot be represented as an exact ratio of two integers. The decimal form of the number never terminates and never has a repeating string of digits. You can forget that basically, because irrational numbers are basically any number that's decimal goes on forever in a non-repeating fashion. So pi would be the most famous example of this, because it's 3.1415926, and it goes on forever without any pattern. This is an irrational number. The square root of 2, when calculated, it would also lead to a rational number, along with the square root of 10, and a lot more other square roots would also do this. And then basically all the decimals that go on forever, when there are these dots, that means they go on forever. And if they don't have any pattern that you see, usually there would be a line over the pattern, so you could tell what the pattern is. In this case, it's just a bunch of random 1s and 0s. So this would be an irrational number. Now for real numbers. So real numbers are basically rational numbers and irrational numbers. But I would also like to take this spot to make some observations. So counting numbers, whole numbers, integers are all inside the rational numbers. So it's like little two worlds, if you want, and inside the rational number space, There's counting numbers, and then the difference between a whole number is just you add 0. The difference between integers is that you add all the negatives. And the difference between rational numbers is that you add the fractions and everything that terminates, all the decimals that terminate. Just take that in. So there are all the numbers that we're usually very comfortable with would be rational numbers. While the irrational numbers, on the other hand, would be numbers that are very strange and go on forever. So that would be these, pi, square root of 2, square root of 10. And then real numbers would be all of these. Now let's do some examples. So let's name all the sets to which the following numbers belong. So if, for example, 1, the answer would be counting numbers, whole numbers, integers, rational numbers, real numbers. So if you want, you can pause the video, and if not, we're going to continue. Okay. So where would 0 belong in here? 0 would probably, will belong in the whole number area, not the counting number and also the integers. But the first thing it would belong to would be whole numbers, and because it belongs to the whole numbers, it belongs to the integers, rational numbers, and real numbers. So the answer to 0 would be is a whole number, integer, rational number, and a real number. Whole, integer, rational, and real. -6 would be an integer. So this would, because it's an integer, it would also be a rational number. And because it's a rational number, it would also be a real number. So -6 would be an integer, rational number, and also a real number. 1/2. 1/2 is none of these, but it is a rational number. So because it's a rational number, it's also a real number. So the answer would be 1/2 is a rational number and a real number. What about pi? So pi would not be in the rational number area. It would be in the irrational number area. Well, you should remember this because it's the most famous example. So if a teacher were to ask you what's an irrational number, you can say pi, or you can say a long string of random, a long decimal with random numbers. And because it's a rational number, don't forget, this is also a real number. So pi is an irrational number and a real number. And what about 2.3? 2.3 would be a rational number, not an integer or a whole number or a counting number. It would just be a rational number and also a real number. So 2.3 is a rational number and real number. Okay, tell whether each number is irrational or rational. You can pause the video and do it yourself. I'm going to continue. Okay, this is actually very easy. So 2/6 is a fraction, and all fractions are rational, along with 3/11, also rational. C, there's a decimal, and it's very long, but it terminates. It ends right there. So that would also be considered rational. D, the square root of 25. Although there are a lot of the examples we did previously, the square roots was actually irrational. The square root of 25 is actually 5, which is a counting number, which is also rational. F is the only one that is irrational because it's a long decimal that goes on forever and has an non-repeating pattern. So that's the only one that's irrational. So that's all you need to know for number sets and the vocabulary that's attached to it. Thank you for watching. I'll see you in the next one.